Yeah, Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. This is a recording for reliability analysis lecture for master's class for UniMap student. Okay. So, okay. Introduction to reliability analysis. So, what is relativity analysis actually? It is a study of performance of system over time, particularly their ability to function without failure under specified conditions. The importance of this analysis is crucial across various industries for ensuring safety, efficiency, and cost effectiveness of system. It helps in predicting potential failures and facilitates better design and maintenance strategies. Okay, so as the name is told, reliability is what we want to make sure that everything is okay. Yeah, everything is good. Then we use reliability analysis lah. Throughout this slide, I will show you how various journals, various researchers in the year 2003 they have done reliability analysis on many things such as satellite communication and everything. They want to make sure that item, that thing that they analysis is performing well. Okay, imagine satellite in the sky, how they can do maintenance on it. Again, it's because it is in the sky. Okay, so it has to make sure it is 100% function. Okay, so like this overview of our reliability analysis in various industries. The first one, of course, in satellite communication and aerospace, because satellite, like I said before, it is in the sky. How can we do maintenance of it? So we must make sure it operate on 100% function. So it focus on enhancing reliability and stability of satellite system, address challenges in operation continuity in complex space environment. Innovative approach like Bayesian environmental importance and dynamic redundancy models. Okay, and then robotics and also automation. Okay, emphasis on kinematic reliability analysis using modular approach, address uncertainty, inaccuracy and efficiency in existing reliability model, utilization of motor function modules and Gaussian distribution methods. Okay, this is in the robotic industry. Okay, and then the nuclear safety and energy sector. It is for development of dynamic reliability and analysis approach for reactor protection system, dynamic address dynamic interaction, time correlation and uncertainties, techniques like dynamic fault tree analysis and Bayesian network modeling. Okay, they use this technique. In other slide, I will explain more on these methods. Okay, human reliability and social system. Okay, we're talking about human itself. Human, of course, we are prone to errors. Okay, we are doing errors every day in our life. Okay, so how can we try to maintain the system, try to maintain the reliability of the human lah. Okay, so integration of human factors in ability analysis, considering non-cooperative behaviors and social networks. Okay, and development of models to assess human error probabilities in complex social technical system, and construction and infrastructure analysis of reinforced concrete structures against progressive collapse. Okay, use of polynomial chaos expansion and sensitivity analysis for various scenarios, assessment of failure properties under different conditions. Okay, so they use also reliability analysis in the construction and infrastructure. For this case, on to analyze reinforced concrete structure. Okay, and healthcare system, reliability analysis of multi-parameter monitoring system in sensitive in ICU, identification of critical components, effective system reliability, modular and parametric modeling for management insights. Okay, so this is some of the objective of reliability analysis. The first one is enhancing accuracy and efficiency, and then sophisticated methodologies uh, such as utilizing advanced method like prediction oriented active sparse polymer coherence expansion past PCE by Zhang Jian and team, targeting traditional challenges such as reducing problem dimensionally and improving error estimation and aerospace sector innovation. Okay, so another objective incorporating human factors. Okay, such as studies like Park Jin Yoon focus on quantifying performance of shaping factors in human gravity analysis. Okay, and then adaptive machine learning method, introduction of machine learning and adaptive method for dynamic responsive reliability analysis, reducing computational demand while maintaining the improving accuracy. Holistic approach. Current trend shows shift towards integrating technical, human, and environmental aspect. Okay, and then handling research challenges in reliability analysis, such as uh, apa, handling of high dimensional data. So, it's because too much data when we are doing analysis, we must consider many factors, all the factors, multi factors. So this is the challenges. A prevalent challenge is the high dimensional extension of data in analysis. Okay, method like elliptic ringing utilized by Wang, T, Chen, and all are being developed to efficiently manage and significant computational demand. Okay, dynamic interaction and uncertainties. Okay, the static method open for short in capturing dynamic interaction. um, what is this? Okay, suppose you are handling one machine. Okay, one machine, let's say one machine CNC machine ke, CNC lathe machine ke, is a static method lah. It's static method. Okay, now we can predict what will happen because the machine is stationary. But what about things that beyond our control, like the weather, like the temperature rise, everything, like the if we go to the supply chain, accident happen, the lorry accident, kan, supply cannot, the war, like the Ukraine Russia war right now, this is all uncertainties. Okay, so this is challenges lah. Okay, non-linear degradation modeling. So conventional linear model are inadequate for accurately representing the non-linear degradation. Okay, cases like uh, Chen Chen Yang Wu exploring non-linear degradation model that integrate with image covariates, highlighting the shift towards more noise and hybridity modeling. Okay, so this research by them, Chang, Yang, and Wu ni, dia like for the image covariates, meaning that we know that artificial intelligence now they can generate images. They can generate images. Okay, along the way, that image you can imagine that image somehow will deteriorate. Kan? Making the more than sometimes it become high quality images, sometimes it become low quality images, not at what we expected. Okay, so this is the thing that uh, we these researchers want to address lah. Quantifying human error probabilities. Okay, human reliability analysis remain a challenging aspect due to in its in inherent inherent complexity and subjective nature of human error. Okay, so research by them ni, Liu Wang et al. On large group human reliability analysis, for instance, address this issue considering aspect behaviors and social relation. Okay, because of course we know human are very complex. Okay, human and a robot. Okay, uh, that's why what we give order to human, uh, they do something else. Okay, so uh, we try to minimize that lah. We try to minimize that. But human, of course, they have the skills that robot cannot do right now lah. Okay. Innovative method in revitalization. This is some of the methods that we use by many researchers. Okay. The first one is polynomial chaos expansion. PCE has become a pivotal tool in revitalization, particularly in context where uncertainty quantification is critical. Okay. Zhang Yan et al. Utilize a prediction oriented practice-based polynomial chaos expansion, past PCE, to enhance efficiency and accuracy of gravity analysis. This model, this model, this method excels in reducing problem dimensionality and obtaining precise local error estimates, overcoming limitation and of traditional PCE-based method. Okay. This method, I will make another slide. I will make another explanation on how the method step by step to do this method lah. Inshallah in the next video lah. Okay. And then adaptive ringing. is a meta model-based approach which been increasingly applied to reduce computational demands in reliability analysis. Okay, these researchers Zhao, Jin, and Lee work on IEAK information entropy-based adaptive cleaning, showcase its effectiveness by employing a sequential sampling strategy based on information entropy. This method achieves significant computational savings while maintaining desired accuracy. Okay, Bayesian network. Most of you, maybe you are familiar with it. Okay, it is has been experimental in modeling complex system, especially where dynamic interaction and uncertainties play a significant role. Okay, Zintao et al. Research on a reactor protection system demonstrate the application of dynamic Bayesian network model. Okay, this approach effectively characterized the dynamic interaction and uncertainties, moving beyond the capabilities of rational static methods. Okay. Another one is advanced sampling strategies, like the I said key apa handling high resolution data. Okay, example of analytic strategies like the one used by Zhao. Itulah this is like the previous note lah. Okay, impact of adaptive strategies. Okay, so uh, the first one is modeling complex system enables robust analysis of system with integrated dynamics and uncertainties and field application, particularly beneficial in aerospace, nuclear safety, and industrial robotics for ensuring system reliability and safety. Machine learning techniques in reliability analysis. Okay, also there are another method you call using machine learning. Okay, support vector machines for enhanced reliability analysis. Okay, application SVM are used for approximating failure probabilities. Advantage they offer improve accuracy in like learning high likelihood region in limit scale function. Case study, uh, Pepper, Crispo, and Motomoli work utilize SVM for adaptive learning, successfully estimating an upper bounds of failure. So machine learning techniques in reliability analysis. Okay, continue on. Deep learning in complex data analysis. Scope deep learning algorithm are particularly effective in handling high dimensional data like images. Okay, for example, Cheng Zhengyu et al. Study on nonlinear degradation models integrated image covariance, showcasing the superiority of deep learning in predictive accuracy, versatility. This model are adaptable, capable of handling various complexities in reliability analysis. Okay. So efficiency in computational method. Okay, reduction in computational demand, both LVM and deep learning method are significantly reduced to the computational load in reliability analysis. Optimization and sampling strategies, they enable more efficient relative sampling strategies. Okay, hybrid model and application. Okay, so the space system, satellite communication system, Zhangwei et al. Employ a hybrid approach combining Markov Bayesian network and multi-objective particle swarm optimization to optimize redundancy design, enhancing the reliability and stability of satellite communication system. Satellite power supply system. Okay, Zhu Dong et al. Developed a dynamic K out of N G model, okay, for satellite power supply system addressing the dynamic nature and failure threshold such as system, thus improving the reliability assessment. Okay. Also, the hybrid model is in industrial robot. So, modular approach for kinematic reliability, Yang, Bin, and Yang. When you propose a modular method focusing on influence of uncertainty in motion function modules using a differential linearization error model and multivariate Gaussian distribution, okay, significantly improving the kinematic reliability analysis of industrial robots. Enhanced computational efficiency, adaptive sampling and multimodal, Zhou Jin Li adaptive cleaning, multimodal based on information entropy and generalized F distribution method provide significant computational savings while maintaining accuracy. Another one is advanced polynomial chaos expansion (PCE). Okay, Zhan Jian et al. Work on prediction-oriented active space method to enhance efficiency and accuracy in the analysis by reducing problem dimensionality and obtaining local error estimates. Okay. So another is human reliability analysis. Okay, large group sense likelihood index model. Okay, Liu Chen et al. Developed a model considering non-cooperative behavior. Okay, social network effectively estimating human error probabilities in complex social technical terms. So dynamic and time dependent system, dynamic reliability of reactor protection system. Zhu Gentao et al. Approach for dynamic reliability analysis of sector of reactor protection system highlight the effectiveness of hybrid model in addressing dynamic interaction and uncertainties in nuclear power plants. Modular approach in dynamic variation network. Okay, industrial robot yang and all study on industrial robots utilizing modular approach and demonstrated enhanced accuracy and productivity by focusing motion function modules and deploying methods like differential linearization error model. They show this study address the accuracy and efficiency issues, showcasing the effective of modular approach and in complex system. Uh, Dynamic Bayesian network for time dependent uncertainties, okay, like reactor protection program and satellite communication system by these two researchers lah, kan. And okay, finally the future outlook of it. Okay, polymer chaos expansion. Zhang et al. Work on active sparse PC illustrate the evolution of reliability analysis techniques. The approach address the challenge is high dimensional problem with improved accuracy and efficiency. Okay. Number two is dynamic Bayesian network. Zhu Jintao et al. Study on reactor protection system using DBNs that presents a lead in handling dynamic interaction and uncertainties in complex system. Okay. Moving beyond the traditional static method. Okay. Satellite system, the work and by Chen Ziwei et al. On satellite communication system using Markov Bayesian network for redundancy design highlight the necessity of tailored approach for specific system, okay, such as particularly challenging environments in particularly in challenging environments like space. And then image covariance integration. Okay, the integration of high dimensional data like in the work of Chen Xingyu et al., where material microstructure image are used in degradation modeling, demonstrate the incorporation of advanced data analysis in reliability studies. Machine learning technique use of support vector machine in reliability analysis and research by paper link shows growing role of machine learning in predicting system failure. And lastly, the AI and machine learning, the IoT as sensor network and human factors. Okay, that's all for this slide. Okay, we'll meet again in another slide. Okay, that's all. Thank you very much. Okay, okay. Goodbye.